సార్ సార్ ఒక్క నిమిషం నా ఫుటేజ్ చూడండి, అది ఒకసారి పోయి చెక్ చేయండి మీరు. రైట్.
ఆడియో వాళ్ళు లేరా మనకి
తీసుకోవాలా? కేబుల్ ఎక్కడ ఉన్నారు? లాక్ చేసుకోండి. పిల్లలు వస్తారు, కొంచెం ఉండు, పిల్లలు వచ్చేస్తారు కదా.
ఆడియో ఎట్లా?
ఆడియో వస్తాడు బాలేదనా? అరే ఆడియో కేబుల్, ఆడియో కేబుల్ ఇవ్వండి.
కేబుల్ మైక్ రాదా?
Some 2 rows, you go to number 421.
Last kelali.
Live section only, they same. Don't feel it, that's what I say.
But then move fast.
This row also, please. Same live session is similar.
Mom. Sir, Vijay sir, after structure తిన్నారు వెళ్ళదని చెప్పండి.
హైట్ కేబుల్ లేదు.
కేబుల్ వద్దు, ఇదే చాలు అంతే.
ఇదే ఇక్కడ నుంచి ఆడియోకి ఇవ్వాలి కదా. నేను ఎక్కడికి ఇవ్వాలి? నేను
దీనికి కెమెరాకి అంతే.
కెమెరా తీస్తారు, కెమెరా తీసి ప్లేయర్కి వెళ్ళా.
వాళ్ళు మాట్లాడేది మీ దగ్గరికి వస్తుంది కదా సార్, అందరికి వినిపిస్తుంది కదా, దాన్ని అవుట్పుట్ తీసుకొని నాకు ఇన్పుట్
ఇన్పుట్ మీకు కేబుల్ అంత దూరం లేదు.
మీరు ముందుగా చెప్పినారు కదా చెప్పేసి
ఉంది అన్నారు.
ఎవరు చెప్పారు?
మీరు ఇస్తారు అన్నారు.
మేము ఇస్తాం.
అదే తిన్నా.
1000 రూపాయలు పెట్టి కమలాలు పెట్టుకోవాలి కదా. ఎంత 20 మీటర్లు పెట్టుకుంటే 20 మీటర్లు పెట్టుకుంటే 1000 రూపాయలు కాదు పెట్టుకోవాలి మీరు ఇవన్నీ.
సరిపోతుందిలేండి ఇది.
ఆ లోపల ఉంది బాక్స్.
సరే చూడండి, లేకపోతే కిందకి వేసుకుంటాను నేను. ఎంత వస్తుందో అంటే
ఇక్కడ దాకా సార్.
Science fair venue is indoor stadium. That first day we will tell. Live link
ఆడుంది పోతాను.
sir, live started.
స్క్రీన్ తిప్పు పక్కకు ఆఫ్ చేస్తావా? దాంట్లో చెక్ చేసి
లేదంటే దాంతో చెక్ చేసి
చెక్ 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 మాట్లాడేది సార్ బస్ అంటుంది సార్. అరే మురళి ఎట్లా వస్తే అట్లా ఇచ్చేయండి కేబుల్.
వాళ్ళ పేర్లు ఉన్నాయని చెప్తారు.
Hello, mic checking. Hello. Nice. Hello. Hello, mic checking. Hello. Hello.
Check, 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 check. వేసుకుంటావా? తీసేది. చెక్ చెక్. అది ఎప్పుడు రోజు వస్తుంది సార్? అది చెక్ చెక్ చెక్. సార్ మైక్ కాలర్ కేసకు సార్ కాలర్ వేసకు అక్కడ సార్ మాట్లాడేకి చేయకపోండి అక్కడ.
హలో హలో నా హలో హలో రాజడు హలో హలో
ఇది ఉంటే చాలా
అంత వాడండి.
ఓకే, మీకు 5 వరకు వస్తాను. ఇది చాలా ఉంటే సరిపోతుందా? ఆన్లో ఉందా? ఇది ఉండాలా?
అది వాడుకుంటారు.
ఇది వాటికి ఇది వాటికి. హలో, ఇది మాట్లాడచ్చన్నా?
Regarding giving of this mementos and
Yes, sir.
this, we need to let him know about the order. We will be giving the mementos to him.
Yes, sir. Madam is totally guiding for that, sir.
Me and Master can you write now? I will give him to Felicitation.
Yes, sir.
Yes, also. Okay. Take care of
Madam.
You're also sharing.
you will see moment from ISRO side. Mementos will be for guests. Okay, so that will be announcing this order. So now we have to tell order. The order we have to tell.
What do we have? Felicitation. Yes, we have.
Okay, so I will take care.
No problem.
Conveniently.
Yeah, yeah.
Sir, you come here, sir. It will be convenient for you, sir. Sir, come this side, sir. It will be better. లేదు మాట్లాడడం లేదు, గైడ్ చేస్తున్నారు సార్. అది మాట్లాడేటప్పుడు అక్కడికి మార్చి నేను నాది అవుతానే మేడంకి ఇచ్చేస్తాను. అవునా సార్, అంటే ఇది అవసరం లేదా? అది బాటికి అది ఓకే, అక్కడికి సార్. ఓకే
Felicitation can be over. After that, next immediately speeches can start. Last we get to other collector is moving before. If he is staying everything till last, then no problem. You can continue. And we have to scroll everything. ISRO and
inaugurating the space one means as well as the space exhibition. After this is over, suppose
Unveiling that topic. But before national anthem?
yeah, no, after national anthem. After national anthem. But in the middle, maybe
Unveiling of
Yes, madam.
nobody is playing until program after national
we complete our program with the national anthem. It's our direction. We should not stop without national anthem. We should not go anywhere.
So after national anthem, if you say that,
Yes, yes. If he is leaving collector, we will send off him and we will come back again. Everybody will be there. People will go and send off him. Immediately we will send him.
training based on needs and science education. First for I request the based on these and
వాళ్ళు మామూలుగా వచ్చి కూర్చుంటారు మేడం.
space on wheels and important sir.
ఇది మేడం
Space on wheels and what is other
స్పేస్ ఆన్
space on wheels okay. Input
స్పేస్ ఆన్ వీల్స్ అంటే 2 డేస్కి జరిగేది కదా మేడం. ఇక్కడ అలాంటిది ఏం లేదు, ఓన్లీ సైన్స్ ఫర్ ఎగ్జిబిషన్స్, రాకెట్ లాంచ్ డెమో అంతే. మేడం వచ్చిందని పెట్టారు.
space on wheels and what is other science exhibition.
சயின்ஸ் எக்ஸிபிஷன். மேடம் அப்போ இந்த ராக்கெட் இயர்ஸ் இதுங்கெல்லாம் கிடையாது, ராக்கெட் லான்ச் டெமோ, ராக்கெட் இயர்ஸ் நாளைக்கு தானே. அப்போ டே 1 டே 2
Afternoon lecture.
ஓகே ஓகே
Afternoon session.
ஓகே. ஸ்பேஸ் ஆன் வீல்ஸ் நெக்ஸ்ட் எக்ஸிபிஷன், ஸ்பேஸ் எக்ஸிபிஷன்.
Sir, at the same time, shawl for all. Sir, for under shawl is but on the Felicitation all are there.
Only for
Let it be, sir. Let it be.
for them we have to felicitate which is best of honors. That's it. Secretary kuda okay. Then two things. Felicitation one thing. So for other things go simply that itself is enough.
Stage on
No need for only 4 months, but okay, we have give all full shadowing the day. How can it be available till tomorrow end? Validity you would organize some
and from your side coordinator, they will felicitate.
That's what I'm telling
They are going away. During the success
Aర్థమైంది.
everything is not we also ran
Lighting the lamp is there.
It is there, sir.
Lighting of the lamp.
First introduction, sir. Introduction.
Okay, and I've done
Lamp is there. Lamp is there. Matchstick and candle is there here. Candle match. Madam, candle match. Okay, sir. Madam, అదే మేడం పెట్టుకున్నారు మేడం.
side means disturbance will not happen. It's what I feel. So that is a normal general practice.
అక్కడ ఎర్త్ ఉందని దాని మీద పెట్టినాం కదా సార్ అది
ఎక్కడ మేడం
సెంటర్ లో ఉంది కదా ల్యాంప్ అది ఏదో దట్ సైడ్ ఆర్ దిస్ సైడ్ పెట్టండి
ఎప్పుడు ఓకే అట్లా కూడా పెట్టేసుకోండి షిఫ్ట్ చేపిస్తాం
ఓకే ఫైన్ విల్ గెట్ ఇట్
ఓకే 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 மேடம் லேம்பை இந்த பக்கம்னா இல்லை அந்த பக்கத்துக்குன்னா நவுத்து சொல்கிறாங்க மேடம் பசங்களுக்கு சொல்லுங்க மேடம் அவரு சார் என்ன கலெக்டர் சாருக்கு எதற்க வச்ச மாதிரி இருக்கும் மூஞ்சி மறைக்கும்ன்றாரு அதுக்காக பசங்க பாய்ஸ் అదే ఇటు లెఫ్ట్ కన్నా పెట్టండి అట్లా రైట్ కన్నా పెట్టండి కలెక్టర్ సార్కి ఎదురుగా ముఖం మీద పెట్టినట్టుంటుంది అని చెప్పి అన్నాడు అది ఇంకేం లేదు అక్కడ రైట్ సైడ్ కన్నా జరిపించండి
Okay.
Okay, sir. Yes.
Whom you want to call? First collect. Candle
ఉన్నాయి సార్ క్యాండిల్ మ్యాచ్ బాక్స్
By hand it should not be.
ట్రేలో పెట్టి ఇవ్వాలి క్యాండిల్ మ్యాచ్ బాక్స్ ట్రేలో పెట్టి ఇవ్వాలి మేడం
లైటింగ్ ల్యాంప్ అని చెప్పేటప్పుడు మీరు వెలిగించండి కానీ ట్రేలో ప్రాక్టీస్ స్టాండర్డ్ ప్రాక్టీస్ అలా తీసుకెళ్ళాలి ఈ ఎదురుగా ఉంటుందా దేవుడిది దాంతో పెట్టుకోండి నేనంటే కాలేజీకి చెప్తాను పేరులో అదైతే మంచిది యాక్చువల్లీ సింబల్ క్యాండిల్ యూ షుడ్ నాట్ యూజ్
ఫస్ట్ ఇంట్రొడక్షన్ మళ్ళీ తర్వాత మేడం ఇస్తారు నేను ఫస్ట్ ఉంటాను మళ్ళీ మేడం వస్తారు ఇద్దరు ఒకేసారి లేదు ఇదా ఓకే ఇది ఓకే ఇది వేరే ఉంది కదా లైవ్ది అందుబాటులో అది ఉండదు కానీ ఇది ఫస్ట్ టైం ఇది పెట్టడం ఇది సార్ అయితే మేడంకి ఇచ్చేసండి లేకపోతే ఇది తీసేస్తాను
స్టిక్ లేదు టేప్ ఏదైనా ఉంటే మెల్లిగా వేసాను చూసి
జోలు వేసుకున్నావు కింద జోలు జోలు పెట్టు
సరే
మైక్ ఎక్కడ దీనికి ఇదా
ఇది మైక్ లెబర్ బ్యాండ్ ఉంటుంది చూడు అది నాకు వచ్చింటాయి కదా ఏడో చోట ఉంటుంది లెబర్ ఒక బ్యాండ్ వేసిన ఉంటాయి సార్
హలో హలో నా ఇప్పుడు కాదు ఇప్పుడు కాదు ఇప్పుడు కలెక్టర్ వాళ్ళందరూ వస్తున్నారు లోపల స్కూల్ బస్సు నుండి వస్తున్నాయన్నా ఇప్పుడు స్కూల్ బస్సు నుండి వస్తున్నాయా లోపలికి ఉన్న మనిషి ఒక అర్ధగంట వస్తున్నారు ప్రోగ్రామ్ స్టార్ట్ అయిన తర్వాత పంపించేస్తాను కలెక్టర్ సార్ లోపలికి వస్తున్నాడు ఆయన వచ్చేసి ప్రోగ్రామ్ స్టార్ట్ అయిపోయి పంపించేస్తాను జనరేటర్ కూడా కరెంట్ పోతే జనరేటర్ టక్కునేసి అది కాదు ముందు బా వేరే మైక్ వేసారు మైక్ మాట్లాడినాడు పోతాను
అవంత ముందుగా తెలుసుకొని తెలుసా నువ్వు ఫోన్ నువ్వు అంత సోకులు అంతా చేతులు పో
ఆపకండి ఆపక సార్ ప్లీజ్ సార్ 1 by 1.
Morning to all. Morning to all the dignitaries, respected guests, faculty members, students, and space enthusiasts. It is with immense pride and excitement that I welcome you all to this two-day.
Karina, తెలీదు
Morning to all the dignitaries, respected guests, faculty members, students, and space enthusiasts. It is with immense pride and excitement that I welcome you all for this two-day celebrations of Science, Innovation, and Inspiration, the National Space Promotion Day 2025, hosted here at Sitams-National Institute of Technology and Management Studies, Chittoor, in collaboration with SDSC, SHER, IPRC, and NAR. This year's theme is Aryabhatta to Gaganyaan, Ancient Wisdom to Infinite Possibilities. Now, the importance of Space Day. National Space Day is observed in India to mark the successful landing of Chandrayaan-3 on the moon in 2023. With this historic achievement, India became the first country to land on the lunar south pole and only the 4th century in the world to land softly on the moon. It was a proud moment for every Indian and a shining example of what dedication, innovation, and teamwork can achieve. On this day, we celebrate not just the success of Chandrayaan-3, but the visionaries and scientists behind the Indian. On this day, we celebrate just the success of Chandrayaan-3, but the visionaries and scientists behind India's space journey, from Dr. Vikram Sarabhai, the father of Indian space program, to the brilliant minds at ISRO who continue to push the boundaries of possibilities. Yes. Now the next 2 days, the existing highlights in this day 1 includes the grand inauguration, a brilliant talk by great scientists and visionaries, a science fair, quiz competition, and a thrilling rocket launch demo by Rocketry's Bangalore-based space startup. And highlights of day 2. Day 2 brings us more expert talks from top scientists from IIST, IIIT, IISRO, and NAR. We will also have a panel discussion and finally the valedictory function where winners will be awarded. Dear students and guests, this program is more than just a celebration. It is an invitation to dream, to innovate, and to look up at the stars with purpose. Let us carry forward the legacy of our scientists, pioneers, and actively participate in shaping the next era of India's space journey. Now over to Raghavi, madam.
Ladies and gentlemen, it's a timeless Indian tradition to begin any new endeavor by invoking the blessings of the Almighty. The lighting of the lamp symbolizes the dispelling of darkness and the triumph of knowledge over ignorance. May I now respectfully request our distinguished dignitaries, Shri Sumit Kumar IAS Garu, District Collector and District Magistrate Chittoor, Dr. Amit Kumar Patra Garu, Director NARL, Srimati B. Shri Felicitation Sir, Guest of Honor, our Secretary Dr. Badri Narayana Sir to lighten the lamp and request dignitaries to join.
गुणशरीराय गुणमण्डिताय गुणेशानाय धीमहि गुणाधीशाय गुणाधीशाय गुणप्रविष्टाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गणेशानाय बालचन्द्राय श्रीगणेशाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय बालचन्द्राय श्रीगणेशाय धीमहि ज्ञानचतुराय ज्ञानप्राणाय ज्ञानान्तरात्मने गानोत्सुकाय गानमत्ताय गानोत्सुकमनसे गुरुपूजिताय गुरुदत्ताय गुरुकुलस्थायिने गुरुविक्रमाय गुल्यप्रवराय गुरवे गुणगुरवे एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय बालचन्द्राय श्रीगणेशाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय बालचन्द्राय श्रीगणेशाय धीमहि.
Thank you, guests. Now I would like to call upon our friend Dr. N. Venkatachalapati Garu to
for the welcome address. Sir.
ఎందరో మహానుభావులు అందరికీ వందనములు. A hearty welcome to all at the National Space Day Celebration 2025. Respected Chief Guest, District Collector of Chittoor, Shri Sumit Kumar, respected Chief Guest, Director NARL, Dr. Amit Kumar Patra, Honorable Guest of Honor, Dr. D.K. Ramkumar, and Scientist, and Dr. Kirti Watson, GM Short, and Honorable Secretary D.K. Badrinaran, and esteemed faculty members, their students, and all the distinguished guests present here today. A very good morning to one and all. It is with immense pleasure and pride that I stand before you to extend a warm and heartfelt welcome to the National Space Day Celebration 2024 at Sitams 26 Years of Excellence. This is truly a special occasion, and we are deeply honored by the presence of our distinguished guests whose support and encouragement are a great source of inspiration to us all. I would like to extend a special welcome to our Chief Guest, Sumit Kumar, the esteemed District Collector of Chittoor. Sir, your dedication to public service and your vision of our district are true motivation. Your presence today highlights the importance of education and scientific innovation in our community. We are also profoundly privileged to have with us a second chief guest, Dr. Amit Kumar Patra, a respectable director of NARL. Your leadership, contributions to India's space research are invaluable. Your expertise and insights undoubtedly ignite the young minds here today, encourage them to reach for the stars. A warm welcome to our guest of honor, scientist uh, Kriti Vasan sir, and we're grateful to your presence for continuous guidance. The theme of this year's celebration, Aryabhatta to Gaganyaan, Ancient Wisdom, Infinite Possibilities, perfectly encapsulates India's incredible journey in space science as a tribute to our rich heritage, starting with the national visionary astronomer Aryabhatta and testament to our future as we embark on missions of like Gaganyaan. This theme reminds us that our present achievements are built upon the knowledge of ancestors, that there are infinite possibilities awaiting to explore. Over the next 2 days, we have a series of engaging activities planned, including inter-school college quiz competitions, space-themed science fair, Space Museum Expo. These events are designed to not only celebrate our nation achievements, but also to foster the spirit of inquiry, innovation, healthy competition among our students. So really, our Honorable Prime Minister celebrated due to that Vikram Sarabhai and Gaganyaan Chandrayaan 3 is a very happy occasion in India. Such a great in India, in this, all the students from various schools and especially Sitams will having so many rural background students, our honorable or founder chairman Sri Adikeshwar Naidu started this institution for developing the rural background students. Thank you once again to your esteemed guest Foundation. Your presence makes this event truly memorable. I also thank you, the faculty students, for their tireless efforts in organizing these celebrations. I hope these 2 days will be enriching, inspiring experience for everyone. Let us all celebrate India trumps in space and look forward a future where our students become a next generation of space pioneers. Thank you. Jai Hind.
Thank you, sir. You are to us Shri T.K. Ramkumar, sir, scientist, engineer, SG from NARS, a brilliant mind contributing significantly to India's space program. As an inspiration to aspiring scientists and engineers. So we look forward to your insights.
నమస్కార్ అందరికీ నమస్కారం. Of the this National Space Day. So this is we are celebrating the second year, the National Space Day. So August 23, 2023, you remember that we had a successful Chandrayaan 3 mission and we successfully landed there. Not simply landing, it is a soft landing. Soft landing means you should be able to get there nicely and do the play. See, around that 6 months, around almost all developed countries launched many missions to Chandrayaan, almost all failed. But we made it there, we went there, and we did some nice sentiment games, mother and child playing there. You know, lander Vikram, and then again, there were nice movement, even such a soft landing. So this is to tell you that, particularly the students, the aim of the main program is that yes, we can go up to that level. This is why Prime Minister announced that day, that successful day, as the National Space Day. And last year we celebrated in Andhra Pradesh, Guntur and Tirupati and Sri Shop Center. And this year we are celebrating in Chittoor, in this college, and then Sririkota Center. So now you can understand the whole Andhra Pradesh, 1 or 2 places only we are celebrating, not the many places. So you take this advantage and you pass this message. The main aim is that to make that young minds, young students. That's why we are putting this many efforts, this much efforts, and gathering, putting our efforts. So this is mainly for you only. So many more things are great. Other speakers are there; they will talk. And with this, I am thank you.
Thank you, sir, for that fascinating address. It's now our immense pleasure to invite our distinguished chief guest to deliver the keynote address. We are deeply honored to have with us our esteemed chief guest, Sri Sumit Kumar IAS Garu, the District Collector and Magistrate of Chittoor, a 2014 batch Indian Administrative Service Officer. Sir brings with him a wealth of experience in public administration and governance. Known for his commitment to transparent and people-centered governance, he has been instrumental in spearheading several developmental and welfare initiatives across.
We wanted to introduce, okay, I'll wait, no problem.
Thank you. Welfare initiatives across the district. His leadership and vision continue to inspire effective governance and inclusive growth. Thank you, sir. Thank you for providing that time.
Thank you very much, ma'am. I am very, very thankful to the institution, Sitams College, that they have invited me today for this program. To their entire team, the principal Garu as well as secretary Garu, and all the professors and the teachers who have worked hard so that this program can be done well in Chittoor. So I'm thankful to everyone. Also, I'm thankful to Anil Kumar Patra sir, their team, National Atomic Research Laboratory, where they have taken their valuable time. They are partnering with a local institution. The team is coming to the institution so that we should learn something about our space program. We should learn something about what is happening outside world. We should learn something about why National Space Day is celebrated. So I'm very, very thankful to their team and the team of scientists and the people who have done hard work so that this day is celebrated. So before I speak, I would request all the students who have come here from this institution as well as from other schools that we should learn something about our history. We should learn something about why we are celebrating this space program. We should learn something about what used to happen before independence. We should learn something about what is happening after independence. So there was a time when India started its space program. We have very, very less resources, and the developed countries refused to share their knowledge, refused to share their resources with us. And then the father of our national space program, Vikram Sarabhai, we must always remember them. Because of his efforts, because of the team efforts, because of the policies at that point of time, India became independent, India became powerful, and India is now trying to basically pursue its space policy in its own terms. So we should always remember, and I would request all the students kindly read about Vikram Sarabhai, what happened at that point of time. You can go to Wikipedia, you can basically search about it. It will give you some knowledge, it will give you some insight at how things unfolded. Also, we should always remember that space program is nothing about space exploration. It is also about our security. It is also, space program is directly linked to our nuclear security also. So because of Vikram Sarabhai efforts at that point of time, the policy, India also became independent in the nuclear space also. That's also a much needed contribution was made, and that is the reason that India is one of the most powerful nuclear country also in the modern time. So today, as students, our responsibility and our constitution also says that the scientific temper, rationality. Scientific temper and rationality are two very, very important terms where we should all as citizens, we should all as students try to understand why these things are important. You have passed, some of you are in 6th class, some of you are in 7th class, some of you have passed 10th class. Most of our learning, if you see, is theoretical these days. We learn something, we read something, we remember something, we go to exams, we just simply write, we pass 8th class, 10th class, etc. But actual you must also reflect whether actual learning is happening or not. Suppose you have a mobile phone. How this mobile phone works? What is a radio wave? What is frequency? What is wavelength? How things are happening? Suppose if we are saying something, how things are getting transmitted to the rooms which are connected by this platform. These are very small things, and if you start understanding learning, then you will develop scientific temper. You will start questioning why things are happening in such manner and why things are not happening in such manner. Why children have very different kind of a noise and why adults have different kinds of a noise. I'm giving small examples to you. So scientific temper, so this is a response, this is an opportunity where you should understand about scientific temper, rationality. Most of the things tomorrow you may not have career opportunity in space, but you may have career opportunities in engineering, the other parts where you will be contributing for the national development. But if you have a scientific temper and rationality, you will be able to do it. So this National Space Day program also gives one opportunity to develop scientific temper amongst ourselves. Not only the learning should be a simple theoretical classroom learning, but also on a practical note also. And these days, as we have access to internet, we have access to computer systems, you should also explore, you should also give your time to these things. Take an example, most of the students, 11th class, 12th class, or degree students, most of the time you may be spending on say Instagram or Facebook or YouTube. Okay. So there also these platforms also offer a lot of knowledge on space exploration program. Try to learn something, try to devote, try to understand the historical perspective, try to understand how technologies work. So you can also spend whatever time you are spending on social media, you can devote some of the time to these aspects also so that you develop scientific temper. And I'm thankful to NARL, their institution, Ministry of Space also, that they have the premier institution in Andhra Pradesh. A lot of researchers are participating in different research areas. They are trying to develop new systems. They are trying to work on those platforms so that our space program moves forward. So I'm very thankful to Patra sir, their team, and I request them to continue doing the same because country needs such institutions. Country need such kind of professionals because if the professionals are good, the institutions are good, then only we can move forward and we would have less reliance on other countries. So I'm very thankful to them. I would also request the college institution that you can also organize 1 day or 2 day meeting to the NARL so that we can interact with the young researcher, from which background they are, from which areas they have come, what they are pursuing. It's a different world altogether. If you read mathematics, it starts from zero, it starts up to infinity. Okay, so it's a completely different world which we are not aware about at all. Different technologies which we are not aware about. If you go there, your mind opens. You also start thinking. There is so much. There is so much out there, and it gives an opportunity to learn more and more. So I would request the college management as well as NARL that if more such training programs, if more such interactions can be planned, definitely it will help to develop scientific temper and rationality. And our students will be also doing good. They'll be also understanding various themes and who knows that somebody amongst us plays a very important role in country's development. So I am hopeful that these next 2 days will provide you an opportunity. I also request you read something. It's an opportunity. It's an awareness program. Understand our history. We have come through tough times, and we are hopeful that India will move forward and will try to achieve what our forefathers had thought about. Thank you very much.
Thank you, sir, for that insightful and motivating address. It's a great honor to have in our midst our distinguished chief guest, Dr. Amit Kumar Patra Garu, the director of NARL, an esteemed institution under ISRO. A renowned scientist in the field of atmospheric and ionospheric physics, Dr. Patra has made significant contributions to radar meteorology, remote sensing, and climate modeling. With over 90 research publications and prestigious fellowships from the Indian Academy of Sciences and the Indian National Science Academy, his works continue to advance India's space and atmospheric research. Sir.
Thank you very much, madam. Sri Shumit Kumar ji, District Collector and Magistrate of Chittoor. Sri D.K. Badrinarayan ji, Secretary of Sitam. Dr. N. Venkatachalapati, Principal of this college, Sitam. Sri V. Kirtivasan, who is our colleague and GM from SDSC Sri Harikota. My colleague, Dr. Ram Kumar here. My colleagues, of course, sitting out of the in the hall. NARL colleagues, all teachers of this college, and my dear students. Very good morning. I think all you know that why we are here. We are here to celebrate the National Space Day. Actually, the Space Day is going to be 23rd of August. This is something that we are doing across the country in many places. This is the second celebration that we are doing. The first happened to be in 2024. I think all you know why this particular day has come. It is in 2023, 23rd August, that we were very successful in soft landing on the moon, on the southern pole. And we are the fourth country to do that. This is a great achievement. A lot of things have happened behind it. And it is very important to celebrate. And we must actually thank Honorable Prime Minister, who actually put on place the kind of effort, the kind of achievement that we have made as a country, and how to actually utilize this and ignite people to take it forward. I want to tell a couple of things associated with science and technology. You know that we also celebrate something called National Science Day. And you know the National Science Day is celebrated for Raman's discovery, for which he was given the Nobel Prize. That is something very remarkable. And why we do it? To sensitize the society that we could achieve something in the field of science, and it was recognized by the whole world. This has sensitized many people, and you know afterwards, in many universities and institutes, the spectroscopy laboratory was set up to take that particular discipline further and expand it to the other domain, the Raman spectroscopy. So many things have happened. That's not the only thing that this India achieved, but that is one moment that had to be celebrated, had to be sensitized, so that everybody learn from it, and then we make progress. So this gives us some encouragement. After that also, there are many things that have happened in the field of science. Many things we have achieved. And using those scientific knowledge, technical knowledge, we have built many things, whether it is in the domain of space, in the domain of atomic energy, in the domain of anything that you talk about, non-conventional energy, many things, those science. But I want to tell, today we are here to celebrate the National Space Day. What is that we have achieved? Okay, and how to actually, utilize this kind of, achievement as an encouragement for us to take it forward. But there are a few things I want to tell. The science that have grown over the years, you talk about, let us say, Raman, or any other science for that matter, we are talking about the new material. A particular material behaves in a different way in different situations. For example, material, when you put in vacuum, it will behave in one manner. You put it in different temperature, it will behave in a different way. You put it in high pressure, it will behave in a different way. Right? So the question is that whether we understand all the science that we have studied in our schools and colleges and universities, whether they are complete. It's not. Einstein has given some theory about relativity, but today it is being challenged. We believe that it is not complete. There is something still not understood. In certain situation, it is not understood. For example, you talk about anything, Boyle's law, Charles' law, anything you talk about, they are applicable in certain condition. If this is constant, this is that, and all these things. You talk about the Ohm's law. It is also applicable when you talk at a constant temperature you talk about. But when you change the temperature, the current changes. The resistance changes of that particular material. So now the question is that now we have access to the space. What new things we can learn about science, both in terms of physics, chemistry, or biology. How a particular material is going to behave in space, and how we can develop new material. How we can learn the property of the material that we can use in new applications. How we can develop many things in the biology about food grains or medicine, drugs, whatever you talk about for our application. Whether we can learn something new from the space environment to which we have now access. The country has achieved that kind of capability to go to space and do experiments. Today we are talking about our own Bharat Antariksha Station. We are able to dream about this because we have developed certain capabilities. We are able to do docking and undocking in space. You imagine there is one spacecraft moving with one velocity, another spacecraft moving with another velocity, and we are able to dock. Dock, you know, shipyards, docking place, correct? So it is dock, it is going to do docking. Two things moving with very high speed, and we have to precisely go exactly in the line and then do the attachment there. We have a relative velocity, and we have to do that in space. So this is not small. You have to understand, it's all relative velocity, you know. You have all tried. The train is moving with this is moving with this, correct? No? So you have done all those kind of calculations. So that has to be done in space when the velocity is so large. Docking and then undocking. Unless you do docking and undocking, you cannot send your people to the space. We are talking about the Bharat Antariksha Station. How can we do that? We have to go and do docking. We have to undock and come back. So these are the things. We are also talking about the human space flight. Why we are talking? Because our people have to go by rocket and go to that space station, do docking, do experiments, spend time, undock, come back, land properly. Correct? So this is something is all driven by science and technology. And every day we are growing. It is very important to know that what we have learned. We have learned definitely many things, but there are many fundamental things that we can question ourselves and we can learn. All that whatever you know in science, this is the principle we are using, but who knows that these principles are going to work there. You are seeing this lamp. It has a flame. It has some structure. If you go to a space platform, it will not do like this. People are talking about the microgravity experiment. What is microgravity? When you go through a lift or free fall, you will realize the weightlessness. This is where you talk about microgravity. The gravity is very small. See, you go to 300 or 400 kilometers, the acceleration due to gravity is not that small. If it is here 9.8, it will be somewhere around 9 there. It's not microgravity. It is that feeling, that weightlessness. Under that situation, how a particular material or a human being is going to behave. How the flow is going, any fluid you are talking about, any material you are talking about, how it is going to behave. Lot of actually this understanding, what we know about science is not complete. Many things we can do about this. And by knowing those things, both in terms of material, both in terms of any other thing, liquid, solid, whatever you talk about biology, some plant generation, its growth or anything. Many things actually you will be able to observe, and you will be tell this is the physics or this is the science that we know it works there, and this is the one which does not work the way we know. There is a deviation. There is much to learn from that difference, and this science is going to be utilized further in exploring space. We are talking about landing on moon, correct? What is the moon's gravity? Moon's gravity, you know, it is 1/6, correct? Earth's gravity is whatever it is. We are able to land here using aeroplane or whatever it is. It has a huge gravity. With 1/6 gravity, we are talking about so difficult to land soft. When the gravity itself is 1/6, it is pulling less, but still we are finding it difficult. So you see in space how difficult it is. We are now going to actually land on Mars. That's the next target. Mars is not here. Moon is our neighbor. Mars is very far. So these are the exercises we are talking about. So we have to talk about what is the basic physics, what is the physics that will work in space, what is the physics that will not work in space, what kind of material behavior we can expect that we are carrying or we ourselves when we are going to the space. Okay, these are something that we have to understand. So there are a lot of laboratory works are going on to synthesize how a human mind or human body is going to behave. And when you go there and come back, how your human mind and body is going to be changed because of the environment there. So many of those experiments linked with called microgravity, they are going on both in terms of material, in terms of biology. I think Shuklaji, who has come back, I think he has done several experiments, and I am sure these results will come very soon, and this will become eye-opener for many of us. This will actually have a lot of insight about what are the areas where we can possibly take it forward. So I think today, I mean, I am talking only one part of the story. Now let me come back from the exploration. Today, what actually space offers to us? Space offers enormous in terms of many applications. Yesterday you heard that there is a place in Uttarakhand which had actually a devastation. A lot of people died. Mudslide, correct? So all these things, you know that recently there was a launch called NISAR, NASA, ISRO, synthetic aperture radar. So it is having two radars, L band and S band. Those who know a little bit about the frequency, these two radar systems are going to do imaging of the Earth, entire Earth. You got any? So we are going to get very fine resolution how the whole things are getting deformed either by the human activity or by natural processes such as earthquake or any other thing, landslide or anything, or the river is changing its path, or deforestation, whatever you call it, civilization, development, whatever you call it. What is that trend that we are seeing, and how to assess and how to make our earth livable and sustainable for future? This is the kind of effort is going on, and this is going to provide us a lot of information about our own planet. And not only that, space is also providing, all this link, you are talking about communication, you are talking about television, you are talking about telemedicine, you are talking about teleeducation, many such things in all domains. You have heard about the Starlink, how it is doing business, so many Starlinks. So a lot of things are coming in this. So space actually offers many things. Space is also integral part of our actually safety, our many establishment. That means it is linked with our defense. Okay, I think Sumit sir has already told you that is a very important component of our sovereignty. Okay? So space is doing in many ways. Space is also doing about the agriculture, assessment of agriculture, flood, forest, climate, atmosphere, environment, many things. Space also can see if the resolution is so good, it will also say tomorrow that where these junks are dumped. Correct, no? So all these, if you want to clean your city, it will be visible in every image. So you have to go and clean it up. So space offers enormous. It offers also enormous actually challenges and opportunity. Now you guys, this is the future, that when it offers so much of challenges, it also brings a lot of opportunities in terms of science, technology, applications, many things. I think our future is bright so far as the space is concerned, because it offers so much in every domain, right from food to security to sustainability to anything. Right? So I think you should actually try to understand that space is not just a small thing. I talked about this thing: material development, electronics, communication. You think that my communication stuff is over? No, it is not over. You are only doing communication in simple way. But when you go for the space communication, you want to do exploration. You want to go to another planet, and also want to go to exoplanet, not in our solar system. It's another system. Okay, so you want to develop a new communication system. So there are a lot of things have to be done if we have to establish a communication in space for our safety. Wherever we are there, we will be able to communicate to our base station from where we are being controlled when we are going for space. So there is plenty of opportunity, even science, engineering, whatever. Science is not just physics, not just electronics or anything, but in the field of biology, in the field of any field you talk about, because it provides you a different environment. That's the microgravity, or you say low pressure, or whatever it is, plasma environment. So it provides a unique opportunity to many facets of science and engineering in space. So it's a totally a different, it's a new domain, a new window to do science, engineering completely in a different way, a fresh look. So I think the door is open, the window is open. So I think we all should actually try to understand what we have done as a country, what our people have done, what were their background, how they have achieved the thing. Why not I? I also should actually see whichever I like, I can take that particular course and then make a progress and contribute to the growth of the country, and then we will have a better life. Our country will become, more knowledgeable, more powerful. That sense. I must tell you, this is a small place, Chittur, and I have always affection to go to a small place for various reasons. I do not want to tell in short. The thing is that you must remember that you think it's a small place, but Chittur is known to the world. I do not know for what other reasons. For one reason I can tell you, Gadanki is known to the world. You know why it is? Because this is the second largest powerful radar in the world of that kind. So if Gadanki is known, we write Gadanki, Chittur district. It is also known. You understand? So you know that thing, and it's so close. It's only 30 kilometers from here. Correct? So you should actually visit such an international facility, such an international center built by us, by our countrymen, totally indigenous. So you should see if our people have made it, we should also understand with what background and what notion and what objective they have made it, and how we can participate, how we can learn, how we can contribute and things like that. So I think I will, at this juncture, I will tell that all of you and anybody sitting elsewhere in the other hall or any other place who is listening to me, please visit. We all welcome you. We have a program every Friday. Typically 200 to 400 students visit us, school, college, everybody. And it's Friday is open. It is for that. Whole day we devote for you. You come, discuss with people, develop relationship, take their phone number, take their contact. If you want to pursue further, pursue further. Okay? So these are all for you. This is a national facility and we are so close to you. So you should actually utilize, and we'll be very happy to host you and provide whatever information you need. And also I will tell the Sitam College management to encourage and develop a program through which this can be formalized, so that there is some program through which some selection, etc., can be done, and people can be engaged in doing certain planned activity to do something meaningfully, not that just a visit and come out, but do something, take a small exercise and do that, so that they go deeper into it. If they like, they like. If they don't like, they don't like. But if they like, they will pursue either here or somewhere else. That is something that we can actually provide, kind of a opportunity to the young minds, young people who are our future, who are the future of this country. I think with this, I think space offers a beautiful opportunity, a new window for learning in science and technology, and whatever we can do small in this small place, we'll be very open, we'll be very happy to host you, spend time with you. Okay, please visit. I think I would like to thank the Sitam management for actually hosting us here, and not only hosting us here, but hosting this particular program for a place from where actually we feel that the people, those who are more interested in core science and technology, they come from rural background. Okay, and we should totally harvest and catch that potential and utilize for the growth of the country. Thank you very much.
Thank you, sir. Thank you for throwing light on the existing opportunities and for your profound talks. We would now like to invite our guest, Shri Kirtivasan Dharu, General Manager at SDSH Shah Sriharikota, a highly accomplished scientist and engineer. He holds degrees in chemical engineering and energy systems. With decades of experience at ISRO, he has played a key role in the development and realization of solid motors used in major launch vehicles like PSLV, GSLV, MK3 and SSLV. He has also contributed significantly to the indigenous development of critical mixing technologies and facilities under the ASMP project. His outstanding contributions in India's space program, he was honored with the ISRO Team Excellence Award in 2015. Sir, we would now like to hear from you.
Good afternoon. The respected dignitaries on the dais, the chief guest, Sumit Kumar ASG, Collector and District Magistrate, Sri Amit Kumar Patraji, Director of NAL, and other dignitaries, the principal, and my dear friends. So today's National Space Day program is about Aryabhatta to Gaganyaan, ancient wisdom to infinite possibilities. So this is the theme of this National Space Day program. So I would like to dwell upon this history of National Space Day. India has made a huge achievement on 23rd of August 2023 by successfully landing Chandrayaan-3, the south pole of moon, on this day. So India has made successful soft landing of this Vikram lander, followed by the deployment of the Pragyan rover. So this has been achieved. Is the first country and India's first country to land on the south pole of the moon. This has been achieved on, and our beloved Prime Minister has also told this success of Chandrayaan-3 is not just India's alone, but also belongs to humanity. So this achievement, the August 23rd, was declared as a National Space Day. Today it's a great honor to be with you and all the bright students here who are the builders of a nation and scientific advancement, and also the teachers of this college, Sitams College. On this occasion, let's understand few achievements of this Chandrayaan mission. Okay, I'll just brief upon this Chandrayaan 1, 2 and 3. Yes, sir. So Chandrayaan 1, discovery of water molecules on the moon. So this was confirmed by the presence of water and hydroxyl molecules on the moon's surface, especially in the polar regions. This was a groundbreaking discovery that changed the global scientific understanding of the moon. Then successful deployment of the Moon Impact Probe. This Moon Impact Probe crash landed near the South Pole, becoming the first Indian object to reach the moon. It's interesting to say that Moon Impact Probe has an image of Indian flag, and Chandrayaan-1 has planted the Indian flag on the moon. So then we'll develop on Chandrayaan-2. So Chandrayaan-2 successfully deployed and the operation that inserted the lunar orbit continues to operate well beyond the lifespan. It's providing high resolution images and data of the moon's surface and exosphere. So it has also detected water and hydroxyl molecules. This was confirmed by the mapped water molecules on the moon. It has used imaging infrared spectrometer to identify water and okay. Chandrayaan 3 successfully soft landed on the moon's south pole. Chandrayaan 3 was the first country to achieve the soft landing, and that area was explored which is not explored by any other country. So this achievement placed India as among the few nations to successfully land on the moon, marking a historic milestone. Okay. This demonstrated the autonomous landing of navigation technology. The mission demonstrated autonomous landing capabilities, overcoming the challenges of lunar terrain. It showcased India's advanced navigation precisely and hazard detection technologies in real time. Chandrayaan 3 success at this location opened doors of future lunar missions and moon's basic exploration. Now the theme of Aryabhatta to Gaganyaan. So I just dwell upon what are the achievements from Aryabhatta in 1975. So ISRO in 1980 was launching the SLV rocket. Okay, that Rohini satellite, it was launched. That was the beginning of SLV. Okay, from 2000 up to 2014, there was a development of PSLV and GSLV series, enabling satellite delivery to various things. Then 2008, we had the Chandrayaan 1. 2013, we have the Mangalyaan, that's a Mars orbiter mission. 2019, we have Chandrayaan 2. And 2023, we had Chandrayaan 3. The future is that Gaganyaan will be launched to Indian astronauts to space. Okay, and then the other things which is that the ancient discoveries which has been done is that India has contributed earlier from the beginning, like the concept of zero, the decimal system, the heliocentric theory, the calculation of length of the year, cataloging stars. Okay, so this I'll just go on about certain earlier very great scientists which were from India, that Aryabhatta. So Aryabhatta was an Indian mathematician. Okay, he has developed when he was only just 23 years old, and that contains about cosmology, mathematics, time calculations, and astronomy. So Aryabhatta used place value system and decimal systems and worked with very large numbers. He gave rational approximation to pi as a 3.1416. Okay, so that was about Aryabhatta, and then we have other scientists, or earlier scientists like Bhaskaracharya, and he also had he's made on a very book called Siddhanta Shiromani, and then he had 4 parts in that, which is arithmetic algebra, planetary mathematics, and spherical astronomy. Okay, this and about certain other aspects we can go about telling about him, and then the Varaha Mihira. So he was an Indian mathematician, and he has developed other same thing similarly, and he was also in. He has developed the sign values and astrology and meteorology, and these things are earlier scientists. So we have all these things because this theme of this space day is also about earlier ancient wisdom. So these are the uh, uh, great scientists which have been from earlier centuries who has developed mathematics and astronomy. So now I'll just this space exploration, as he has told, has been can be categorized into some sort of communication, remote sensing, or space science. Okay, that ISRO is always active in this area of explorations. And now we have the communication satellites like GSAT or Cartosat or the recent NISAR and Auditya L1 and Artosat, etc. So to enhance this life of human life, ISRO has been focusing on Chandrayaan 4, that is continuing exploration of the moon, this Gaganyaan human space mission, and also Mangalyaan 2, the continuing exploration of Mars and reusable launch vehicles. Then we have the Shukrayaan, study of the Venus. Okay, this journey towards missions, ISRO has involved in new technologies like supercapacitors, thermal protection systems, and also many sensors like MEMS. ISRO is also carrying out several programs like Yuvika, World Space Week, National Space Day, encourage young minds into space exploration towards better India. Okay, so this I encourage all the students to participate. I thank the organizers for giving the opportunity to address this gathering. Thank you. Jai Hind.
Thank you, sir. We'd now like to felicitate our chief guest. May I request our secretary, sir, to felicitate our chief guest, Shri Sumit Kumar Garu, IAS, and along with him, may I request Dr. A.K. Patra, sir, to present the memento. May I now request our esteemed secretary, Shri D.K. Badrinarayana, sir, to felicitate. May I request Amit Kumar Patra, sir, to felicitate secretary, sir. May I now request Dr. A.K. Patra, sir, to present the memento to Dr. Kirti Vasan, sir, and request our secretary to present the shawl. May I now request Shri T.K. Ramkumar, sir, to present the memento and shawl to Dr. A.K. Patra, sir. Thank you, sir.
Secretary, memento to secretary.
Okay. May I request our chief guest to present the memento and the shawl to our secretary, sir. Anthony. Thank you, everyone. The success of any event is a collective effort, and we have many people to thank. To express our gratitude and offer the vote of thanks, I would now like to call upon the coordinator of this event, Dr. S. Vijay Kumar, sir.
Good morning, respected delegates and our visitors, participating students. With immense pleasure and privilege, I am here to happy to convey my sincere thanks to the dignitaries on the dais. First of all, I convey my heartfelt gratitude to a person of simplicity as well as most powerful personality of the district, who is our district collector, Sri Sumit Kumar IAS. Thank you for your presence amidst your busy schedule. You came here and graced the occasion. Thank you, sir. Next, my words of precious thanks to an inspiring man by actual fact about the real scenario, the knowledge based on artificial intelligence, data science, environmental science, space science, etc., who is none other than our beloved chief guest, Dr. Amit Kumar Patra Garu. Thank you for your motivations and presence throughout this event to make this event a grand success. Thank you, sir. My sincere words of gratitude goes to our chief guest and guest of honor, who is the General Manager SMPC, SDSC SHAR, who is briefing the history of satellite navigation. Actually, the whole history, he briefed it in a short period. Okay. Only few minutes he spoke. If the space science someone knows, it is really a history, or otherwise I can say like highlights. All these satellites starting from its mission. Okay, from its beginning of ISRO, he briefed it, who is none other than our guest of honor, Felicitation, sir. Thank you, sir, for your presence. My sincere thanks go to the subcommittee chair, Dr. T.K. Ramkumar, sir, for his until effort throughout this past 2-3 weeks. We made a lot of efforts to make this event a grand success. Thank you, Ramkumar, sir. And my sincere thanks goes to Sivans Tripathi and Rajendra Prasad, sir, and all the NARL team. Thank you for your cooperation. Without your guidance, it is not possible to make this inaugural ceremony a successful one. Thank you all the NRL team members. Gupta sir also, he made a lot of insightful inputs. Thank you, sir. And the word of appreciation goes to the management. Without the management support, it is not possible. The members in absentia, our trustee Kalpaja madam, chairman Ranganathan sir, and advisor and our own beloved secretary Badrinayana Garu. Thank you for your support, sir. Thank you. And I thank our faculty team, our principal Garu, Dr. N. Venkatachalamurthy, principal Sitams, Dean Academics, and all the HODs and committee members, as well as last but not least, the student participants, without whom it is not possible to make it success. Your knowledge, you are to gain the knowledge through this 2 days workshop. I am sure you are going to gain a lot of insightful things related to space. Thank you, one and all.
To conclude this event, we request you all to join to the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंधु गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभाशिष मागे गाहे तव जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे जय
Rocket launching.
So the rocket launching is arranged at ground. The audience can go there. Inauguration part. Please announce the inauguration. Space museum.
Inauguration of Space on Wheels, right?
Silence.
Yes, hold on for a while.
Excuse me.
Please maintain silence until the dignitaries leave this hall. Please keep it silent. That's after this. After the dignitaries move on, you please come along with us to see the real rocket launching. And there is a national ceremony.
Let them.
Okay.
All the participants.
Sir, first year students back to class. First year students back to their class for technical work.
Please for the inauguration part. Inauguration part, you did not tell about it, right? They also don't know.
Okay. Students, just maintain silence.
Today we have started a 2 days program to celebrate National Space Day. This particular program is being coordinated by Satish Dhawan Space Center, Sriharikota, National Atmospheric Research Laboratory, Rajanki, and the Sitams-National. The whole idea is to actually tell our young minds about the achievement of the space and in the domain of space, and to celebrate the National Space Day, and also to generate awareness about science and technology, which actually gives us so much of opportunity for utilizing the space for humankind, for our society, for the growth of the country. So the effort will be put in for next 2 days to make the awareness program, giving several tutorials, not tutorials, the lectures basically about the information, the kind of achievement we have done in this country, what kind of opportunity challenges we have before us that we have to tackle for many, many applications in our society, and also to get benefit from the space program. He has been there for a long time. I am there for a longer time. Probably don't.
from solar system X-ray astronomy to the modeling of aurora, air glow, and photochemistry in planetary atmosphere. His research has been featured in press releases by NASA, ESA, and ISRO, and he has appeared on cover pages of top scientific journals. With over 170 peer-reviewed publications and numerous book chapters, including in the Encyclopedia of the Solar System, Professor Bharadwaj is also deeply committed to academic mentorship. He has guided many PhD, MTech, and MPhil students and contributed to the academic growth of the space science community. His contributions have earned him some of the India's highest scientific honors, including Shan Swarup Bhatnagar Prize and Infosys Prize in Physical Sciences. He currently holds the prestigious Sitams-National Fellowship. We are truly fortunate to have the opportunity to hear from someone who has been at the forefront of India's space exploration journey and who continues to inspire generations of scientists and students alike. Please join me in welcoming Professor Anil Bharadwaj.
I hope you can hear me well.
Yes.
Let me just share my screen and see whether things are not well. Can you see the screen?
Yes,
Can we confirm that you can see the screen?
Yes, sir. Yes, sir. We can see your screen.
Hello.
Unmute.
Hello.
Yes, sir. We can see your screen.
That's the full screen?
Yes, sir. No. It's not full screen, sir. Now it's full screen.
Okay. And is it? How do I do this? So can I move this screen now? How do I move it? Wait. I think there is some issue. So I'm here. Okay. And I do share the screen. Are you able to see anything? Okay. Share. Okay, now?
Yes.
Okay, so you can see the screen now, right? It is moving? Okay, perfect. No, I got it. Okay, good. So, thank you. Good morning, everyone. But it is good afternoon now. And I thank all the organizers of Srinivasa Institute of Technology and Management Studies, Institute, and my colleagues from ISRO, from MARL, from other institutes, the centers who are organizing this National Space Day, which is essentially to celebrate the success of India landing on the moon last year on 23rd of August, which is now called as the National Space Day. And this is a very important landmark achievement for India, that we landed on 23rd of August at the Shiv Shakti point, which is in the southern polar region of India. So I will give you a brief account of how exploration of the whole solar system is happening in India, and what are the programs which has already been conducted under this, essentially the missions, and what they are planning to do in the future. Okay? So, as you must be aware that I am from Physical Science Laboratory in Ahmedabad, in Gujarat currently, and the domain of expertise of PRL varies from very large ranges because this is an institute which was established by Dr. Vikram Sarabhai in the year 1987, and it was the year of independence. And so this institute is about 77, more than 77-year-old, and this whole institute slowly grew up to form ISRO, which happened in 1969, and then Department of Space in 1970. So PRL can be considered as the mother of this. And currently, if you look at the gamut of research activities in PRL, it is ranging from astrophysics to solar physics to space science to planetary science to geoscience to theoretical physics and atomic molecular. These are very broad domains, but there are many sub-disciplines inside that, for example, biogeochemistry, astrochemistry, solar system science, instrumentation, theory, modeling, everything is carried out with the aim of doing internationally competitive research. Okay? Now, if you look at our solar system, we say now that we have 8 planets in our solar system. Essentially because Pluto is not considered as a classical planet. And if you look at this picture, can somebody confirm that they are able to see the full screen and everything is fine? So,
Yes, sir.
okay, perfect, very good. So we have 4 inner planets, Mercury, Venus, Earth and Mars. And we have 4 outer planets, Jupiter, Saturn, Venus and Neptune. So the inner planets are called terrestrial planets, they are small in size, whereas outer planets are much bigger in size and they are called giant planets or gaseous planets or icy giants. Now if you compare this inner planet to the outer planets and look at just the inner planets, then you say Venus and Earth are same size, Mars is half, Mercury is 1/3. And then if you compare them with the outer planets, then you say Jupiter is the biggest, next to Saturn, then Uranus, then Neptune, and Earth is the 5th largest planet, right? But now if you compare with respect to Sun, how big we are small dot. More than 100 Earth can sit inside the Sun. And on this Earth, you can imagine how big we are, or how big India is, or how big Chittoor is, and then your own institute and yours. So we are very, very small with respect to the size of the Sun is. And if you look at this picture, which is the whole disk of the Sun, and you put the features like sunspots on Sun, which you are seeing here, numbered as 12192, 12193, and things like that, and the size of the Earth itself. You can imagine how big the Sun is. or synthetic aperture radar, you are actually using radio waves in L and S band to probe beneath the surface, not on the surface. Or various other instruments like CHASE-2, IRS, FLASK, providing us information about the water distribution, about the mineral composition and their distribution. For example, R140 distribution from CHASE-2 and elemental composition. And for getting the composition with respect to its abundance, we need to know how much solar flux is actually coming on the lunar surface. And that is possible by an instrument called XSM, which is built by PRA and is also currently operating. And this provides you X-rays, which is coming from the sun and falling on the lunar surface, exciting these elements on the surface through a process called X-ray fluorescence, and we get the element. So this is the instrument which provides you how much solar flux is coming and hitting lunar surface. And if you look at the plot on the bottom, which is more than 5 years long plot, you are able to see how things are changing with respect to the solar activity. So this is a plot from September 2019 to almost like July of 2025. Chandrayaan 3 mission, very complex and complicated because it not only had a simple propulsion module on orbiter, but also has a lander, that's the Vikram lander, and the Pragyan rover sitting inside. We had the fantastic launch on 14th of July 2023, and both lander and rover carried experiments which are developed in India, and PRL was involved in an instrument called APXS, Alpha Particle X-ray Spectrometer, to determine the elemental composition lunar surface. We also had LEO's instrument called LIPS, Laser Induced Breakdown Spectroscopy, and both of these instruments were on the rover. Whereas on the lander, which landed onto lunar surface, we had Ramba LP, we had CHASE, and ILSA. And I will tell you a little bit about that as I progress. So you see all these instruments after landing. This picture you must have seen in the center one with the Vikram lander sitting on the lunar surface. And this was an image taken by the Pragyan rover, which was moving on to the lunar surface. And it very clearly shows that, yes, the instruments are perfectly deployed. The CHASE, which you see as a probe going inside the lunar surface up to a depth of 10 centimeters. Whereas ILSA is measuring the seismicity or seismic activities onto lunar surface. Both are deployed very well. And Ramba LP, which was also an instrument at a height of about 2 meters on the top deck of the lander, was deployed very well. Now, where do we land? We landed into the south polar regions. We call it Shiv Shakti. So this is the first time any country has gone into the southern polar region. That's why India has created history by going to this location where nobody has gone. And therefore we are able to get some new information which was not available so far from any missions which has been carried out since Apollo lunar time till the Chang'e missions. Now these instruments which I just mentioned, for example CHASE, has provided us information about the temperature falling within the top 10 centimeters. And if you really look at that, this top profile, it shows that almost like 50 degrees centigrade, 50 degree change in temperature from the surface to beneath the 10 centimeters. That means lunar soil, lunar regolith is highly known content. The bottom one gives you the electron distribution or plasma distribution, I will say, very close to the lunar surface and an altitude of about 2 meters. Whereas ILSA, which is measuring the seismic waves at the landing site, was able to capture any signal which is coming from the rover movement. So as the rover was moving over a period of almost like 12 days onto the lunar surface, we are able to capture the seismic waves. But also we got information about many other activities, including moonquakes or meteoroid impacts happening into the lunar surface. The APXS instrument has provided us information about various elements present on the lunar surface, whether it's sodium, magnesium, aluminum, silicon, sulfur, potassium, calcium, titanium, chromium, manganese, iron, nickel, things like that. And if you look at this into more detail, which is shown over here, this was the first time we got this information from almost like southern polar region, and it also gave us new information about the higher abundance of magnesium compared to other places. This important paper was published in Nature. And you can see this, of how the rover has made observations at different locations close to the landing site of the Vikram lander. What we are planning to do next? We are planning to have mission to study the moon in more detail. So far we have only landed and did rovering or moving onto lunar surface and did science using instruments sitting on the lander and rover. But now our plan is to go land and bring back the samples. Therefore, you may be seeing this different modules like propulsion module, descent module, ascent module, transfer module, and re-entry module. So what we have to first do, we have to go into an orbit around the moon, do a landing on lunar surface, collect the samples into the ascent module, bring this ascent module into a module which is already orbiting in the moon. So we have to do docking in the moon orbit. Then this will come back to Earth, right? And then we have to again do undocking to do a re-entry of that module into the Earth orbit and come to the surface of the Earth where we will collect back the samples. So this is a very complex mission which a lot of dockings coming into picture, and that is why you must have heard about, ISRO has successfully did demonstration of docking in the orbit using a mission called SpaceX. And this is actually a preparation which is going on for taking or undertaking complex missions like Chandrayaan-4 sample return missions. But this is going to be a very important mission because India is going to bring samples from the region so far not attempted by any of the countries. We are also talking about exploring the polar regions, particularly the permanently shadowed regions or PSR. If you can see this image on the left side in the bottom, you are seeing these black areas, black patches, right? These are actually craters. Craters at almost like 90-degree south. That means these craters are not able to see sunlight ever. Essentially because the moon is almost vertical. And this is how it goes around the Earth. So if you have craters in the polar regions, both north and south, they will never see the sunlight because photons move in a straight line, right? So that means they will be like deep freeze. The temperatures will go down to something like 50 Kelvin, 30 Kelvin kind of things. But then you have to land into a region where you need to produce power, right? So that means you should land in a region which is sunlit, but probe the region which is completely. So these are very, very stringent requirement on a mission where you need power generation using solar panels. So you should land in a sunlit region, and then using a rover, you go into deep into a crater which is called permanently shadowed regions, probe what is present there because nobody is so far knowing what is there. We expect a lot of volatiles, including water in these regions, and therefore it is very, very important for us for future exploration and probably human settlement on the moon that we should know how much water is present there and what are the other things which is present there, what are the volatiles which is present there. And therefore this mission is very important, which we call as Chandrayaan-5 mission, which is an ISRO JAXA or India-Japan mission. It is also called as LUPEX or Lunar Polar Exploration Mission, where lander is going to be provided by India or ISRO, whereas the launcher and the rover is being developed by JAXA or Japan. And there is a joint experiments on the rover which is going to go on this. So we have instruments from India and from Japan on the rover which will do science in this permanently shadowed regions. You must have also heard about Aditya L1 mission, which is also an observatory at L1 point. And this is an observatory to study the sun, which has 7 experiments, 4 of them remote sensing, working in the X-ray, ultraviolet and visible. or in the X-ray regime. So it's basically visible, ultraviolet and X-ray. And it provides you information instantaneously of activity happening on the sun from a point called L1. I will tell you a little bit about that. But it also has in situ measurements to study the plasma which is coming from the sun. A speed of about 400 km per second, which is called as solar wind. And I was mentioning you how solar wind interacts with the moon. Also, this is a very important mission because L1 point is a point, just go to the next one, is a point which is on a line, imaginary line you can say, joining Sun and Earth. So if you look at L1, as the Earth is going around the Sun, L1 also goes around the Sun. It is not going around the Earth, so there is never an eclipse for a spacecraft. And that's why you are able to continuously see the spacecraft can continuously see the Sun. That's a big advantage of this mission. And with Aditya L1 continuously providing us information, this is the whole spacecraft, where you can see different instruments situated at different locations. And this front side which you are seeing is continuously seeing this. So there are 7 experiments which are currently being operated, and excellent quality of data is coming out from this mission. In future, we are talking about probing Venus, and also a very elaborated mission to study the Mars. I just talked to you about Mars exploration, right, using the Mars orbiter mission on the Mangalyaan. But now our idea is to land onto the Mars. But not just land, start moving. So this is a mission which is going to be a very important mission to probe the Mars. But we are also talking about a mission to Venus, which will be in orbit, because we are going for the first time to probe the Venus. Venus is a very weird planet, and it has a lot of features, including that the surface of the Venus is not visible in optical or visible light, essentially because Venus is covered by clouds. So this picture which you're seeing, of Venus in the bottom, right, is not the surface picture. It is of the clouds, because we can't see the surface of Venus in visible light. And there are many other features, including, for example, Venus is dominated by carbon dioxide, similar to Mars. Now you imagine you have a planet Earth, which is in the middle of Venus on one side and Mars on the other side, right? So how is it that Venus and Mars have CO2 dominated atmosphere, whereas Earth has N2 and O as dominant gases? So that means as the evolution of the different planets happens, there is some features or some activities on Earth which made its atmosphere very different compared to these two planets. And therefore, we should study them to understand how the Earth has actually evolved. So there are many other aspects in addition to studying this planet itself that you come to know about how the solar system evolved and how different planets have undergone different evolution histories. And then, of course, many features which will happen on a planet dominated by carbon dioxide, but may not happen on a planet like Earth dominated by nitrogen and oxygen. So with this, I would like to thank you all for listening patiently, and if there are 1 or 2 questions, I can take it. So thank you all, and all the best for National Space Day celebration at Sitams, that is Srinivas Institute of Technology and Mathematics. Thank you. Thank you so much.
Do we have any questions? No? Don't worry, you can ask. It need not be very complex question. Yeah?
Hello, can you hear me?
Yes, sir. Good afternoon, sir. I'm
Yes.
Dr. Priyadashri, sir, from MBA department. So all the contents that you said, really it was very surprising for me. What kind of contributions you scientists are doing for this country. But as management people, sir, we also have that willingness to do something in this related to ISRO or some contribution to the country. So do we have any scopes? Anyway, what we can do?
See, the data which is coming out from these missions are open to public. Okay, so if you are interested to analyze any data which has come out from any other mission like Chandrayaan 1, Chandrayaan 2, Chandrayaan 3, Aditya 1, Mars orbiter mission, they are open to public. They are kept in the ISRO's what they called as ISSDC or ISRO Space Science Data Center, and you can create a login and password there and then access the data. It also contains a lot of softwares and features where you can understand what this data is and do the analysis. So this is like directly using the data coming out from these missions. If you are also interested in contributing to development activities of any of these instruments, you can coordinate or collaborate or cooperate with different centers which are actually developing these instruments. So this is how you can actually participate. Okay?
Thank you so much, sir. Sir, another question, sir, from my side on behalf of the student. What could be the application or usages of this? India spends such a lot of amount on this, so much of expenditure goes on to this. What kind of benefits do we get from these missions?
I think you're asking a question, what benefit we get from these
on these missions, what kind of outcomes, what kind of applications we go for using this? What would be the benefit out of it?
See, there are n number of benefits will come out. First and foremost, when you talk about any mission, which is particularly like Chandrayaan, the whole country gets excited, right? And it is more important for our children who are school going or college going. They come to know the achievement of the country. So it's a boon for them to know that the science in the country has developed to a level that we are able to go to the moon, we are able to go to the Mars, and they can also dream of doing such kind of missions. More recently, you must have heard about Shubham Shukla, going into International Space Station, which is basically again a landmark for India, because now kids can dream of going into space. And in future, we are talking about developing our own Bharatiya space station of India, and Indian landing onto the moon. So you need to have excitement among the students, excitement among the public, and these missions actually help to do that. So this is about how do you encourage the students to take up science. Secondly, when you do this kind of missions, there are many technologies which get developed and which has applications not just for space science. You have very what you call requirements for a material which is very light but very sturdy or very strong, right? So that you don't have to spend much fuel to take it up in space. And they have applications in many other disciplines of science and technology, including humans, for example, artificial limbs. The artificial limbs requirement is that it should be light material but very strong. Right? This is come out from space technology development activities. There are many other applications, so I don't want to take time to deal with each one of them, but I can tell you that many technologies which we call a spin-off come out from this kind of development activities, which actually goes into public domain. I hope things are clear to all of you.
Yes, sir.
And shall I take leave because I have another people waiting for me for a meeting?
Yes, sir. Yes, sir. Thank you so much, sir, for your wonderful interaction with students as well as faculty experts are here in all domains. Your insightful lecture is definitely going to get information, some more information detail added to our knowledge. Thank you for your valuable time, sir.
Thank you so much for the invitation, and all the very best for the day's activities. What's the plan?
Hello. Thank you very much from the NARL side, sir. So last year also you have agreed to give a lecture in MBU University as a part of this National Space Day itself. So we are very glad that you have agreed to give this live talk. So you are a truly inspiring personality for the students here. So it means a lot to us. Thank you, sir.
Thank you so much. I'm just logging it up. Huh? Okay. Take care. Bye bye.
Now all the first year students, after lunch you should be back to the gallery.
எந்த ரூம்ல இருக்கிற நீ
2015, right here in Bangalore, by two passionate aerospace engineers, Mr. Divya Anushu and Mr. Akash, both alumni of the prestigious Indian Institute of Space Science and Technology. With their deep interest in rocketry and education, they launched Rocketers with one vision to bring real-world space science into classrooms and make model rocketry accessible to students across India. What makes Rocketers truly special is that it became India's first startup to manufacture and sell solid fuel model rocket kits commercially. Their rocket kits are not just toys. They are functional, safe and educational. Some of their models can reach heights of up to 900 feet and even carry small payloads and sensors or cameras. Rocketers is more than just a rocket company. They are deeply committed to STEM education. They conduct hands-on workshops both online and offline. These students learn the physics, maths and engineering behind rocket science. Their programs are designed to align with India's National Education Policy 2020. And they even help schools set up dedicated rocketry labs. One of their proudest moments came when they entered to Guinness Book of World Records by organizing 497 stabilized rockets launched by students during the India International Science Festival in Goa. That event was held in collaboration with ISRO and Viyagan Bharati, a true celebration of science and youth innovation. Till date, Rocketers has helped over 50,000 students launch real rockets. They have also worked closely with ISRO as an official outreach partner, even contributing rockets for the prestigious Yuvika program, which is ISRO initiated with engaged young space enthusiasts. With a growing community of learners, innovators and educators, Rocketry is proving that India's future is space exploration starts with the classroom. By igniting young minds through hands-on rocketry, they are not only teaching science, they are building the next generation of scientists, engineers and space pioneers. Let us take a moment to appreciate the amazing work being done by Rocketers Bangalore and the inspiration they bring to young learners all over the country. Now, we are honored by your presence and look forward to learning from your invaluable insights. Thank you.
Hi everyone, can you guys hear me? So you're all from the same college, right? No one is outside the college? No one seems to talk apparently? No one is from school, right? No school students? Okay, alright. So it's a mix, fine. Before going into the session, I'll tell you brief about what this session is going to be, okay? Usually I start with my introduction, but I'll keep that towards the end. Let me finish the session and then come back to my introduction, okay? So this session is going to be about rocket science, and you cannot learn rocket science in 1 hour or 2 hours. That is not practical exactly. So instead of teaching you about rockets, I will discuss about some interesting stories behind the history of rockets, how rockets work, and few very interesting videos of how these things work in real life. Okay? And so whatever you saw in the morning, the kind of a failed attempt to launch rocket, so we're going to be launching the same rocket after this session, another 3 rockets, and I will also tell you how those things work and why we build those rockets. Okay? How many of you know about this hobby called model rockets? No one has heard about model rockets? None? Okay, so this is a very common hobby in other countries, US, Europe and Canada. What these people do is, you can buy spare components and the fuel from commercial suppliers, build rockets and launch rockets. You don't have to work for a company to build rockets actually. So these are all hobby stuff. This is very common in other countries. But unfortunately in India, if you want to launch rockets, well, you need to get a degree and go work for a company, probably ISRO or other private space companies. If you want to start small, if you want to build small rockets, you cannot do that, unfortunately, because there are no suppliers who manufacture these kind of rockets. Until these people showed up, Rocketeers, and there are a couple of other companies right now who manufacture and sell these kinds of rockets, wherein you can place an order online, buy the components, assemble it by yourself, and launch it in an open area. So this wasn't in existence before, okay? So yeah, this is the hobby of model rockets in other countries, okay? So you'll get a very rough idea of what this hobby is from this video. This is not in India again, this is other countries.
By day, I'm a venture capitalist. On weekends, I love rockets. I love photography, I love rockets. I'm going to talk to you about a hobby that can scale and show you some photos that I've taken over the years with kids like these, kids that hopefully will grow up to love rocketry and eventually become maybe another Richard Branson or Diamandis. My son designed a rocket that became stable, a golf ball rocket. I thought it was quite an interesting experiment in the principles of rocket science, and it flies straight as an arrow. Baking soda and vinegar. Night shots are beautiful, piercing the Big Dipper and the Milky Way. 2 stage rockets with video cameras on them, onboard computers logging their flights, rocket gliders that fly back to Earth. I use RockSim to simulate flights before they go to see if they'll break supersonic or not, and then fly them with onboard computers to verify their performance. But to launch the really big stuff, you go to the middle of nowhere, Black Rock Desert, where dangerous things happen. And the boys get bigger, and the rockets get bigger. And they use motors that literally use on cruise missile boosters. They rumble the belly and leaving photographers in awe watching the spectacle. These rockets use experimental motors like nitrous oxide. They use solid propellant most frequently. It's a strange kind of love. We have a rocketmavericks.com website with my photos. If you want to learn more about this, participate, be a spectator. Mavericks, we had to call it Rocket Mavericks. This one was great. It went to 100,000 feet, but didn't quite. It actually went 11 feet into the solid clay. It became a bunker buster. Drilling down into the clay had to be dug out. Rockets often spiral out of control if you put too much propellant in them. Here was a drag race. At night, you can see what happened in a second. Daytime, we call them land sharks. Sometimes they just explode before your eyes or come down supersonic. To take this shot, what I often do is just go way beyond the pads where none of the other spectators are. And if we can run the video, I'll show you what it took to get this DreamWorks shot. This is rare. Here's when they realize the computer has failed. They're yelling to play. No, this is when they realize everything on board is going haywire. Oh, shit. And I'll just be quiet. And that's me over there taking photos the whole way. Things often go wrong. Some people watch this event because of a NASCAR-like fascination with things bumping, grinding, burning the parachute as it fell. That was last weekend. This guy went up with supersonic, ripped the fin can off, yard sale in the sky, and a burning metal hunk coming back. These things would drop down from above all through the weekend of rocket launch after rocket launch after rocket launch. It's a cadence you can't quite imagine. And in many ways, I try to capture the mishaps. It's a challenge in photography when these things all take place in a fraction of a second. Why do they do it? It's for things like this. Gene from Alabama drives out there with this rocket that he's built with X-ray sensors, video cameras, astute with electronics, and he succeeds getting to 100,000 feet, leaving the atmosphere, seeing a thin blue line of space. It is this breathtaking image of success, of course, that motivates us, and motivates kids to follow and understand rocket science, to understand the importance of physics and math, and in many ways to sort of have that awe and exploration of the frontiers of the unknown. Thank you.
So, almost all the people who were launching rockets, including that guy, so they started with this rocket. This is the basic, a C-class rocket, okay? So you can start from this and go as high as this video. Now, these people don't work for NASA or other space companies, by the way. They build rockets in their garage, alright, backyard, without any degrees and stuff. All they have to understand is basic principles of how rockets work and some design knowledge, alright? So here's another one. Bunch of people spend some money to design and launch these kind of rockets. whatever knowledge it takes for you to build these kind of rockets, you can apply the same knowledge and principles to build rockets that go to that altitude. By the way, how high do you think that is? That's not space. It looks like space. It's not space. That is just 35 kilometers. That's called near space. So once you cross that 30 kilometers altitude, that's how the sky looks like. Complete dark. So they have put a small GoPro action camera inside the rocket, and that is how they could take all these videos. So people who are into your engineering, doing mechanical and other branches, you are way well equipped with knowledge than these people. So if these people can do these kind of projects, well, you can do more than this. So that's the whole point of this talk, okay? So as I told you, I'm not going to talk about physics and all the equations and stuff, which gets boring at some point. You need to really have patience for that. But instead, I'll share a few interesting stories about these things, so that you'll get that curiosity on, so that you can explore about this after this session, probably, okay? And also, if you want to make this session interesting, it's better you talk, because if I keep talking, it'd be like your typical lecture, me talking and you staring at me. Well, it gets boring at some point. So the more questions you ask, the more I can discuss about these things, okay? Yeah. You're all comfortable with the language, right? You can also ask questions in your own language. I understand all the languages. So, but I will answer in English, but you can ask questions in whatever language you want. But please do ask questions. All right? So I made this presentation for a 2.5 hour session. I'm not going to go through all the slides. I'll skip most of the slides. I'm going to condense this into 30 to 40 minute session max. But if it gets interesting, well, we can extend this further. Can anyone tell me what is a rocket? Don't go to your definition and stuff. If I tell rocket, what comes to your mind? Whatever comes to your mind. Escaping from gravity, right? Anything else? That goes to space, carrying payload. All these answers not from students. You can talk, you don't have to stand up. I won't know that you're talking because I cannot see most of the people. So you can just tell. Yeah.
Because it is not only one man show. Feel free, even though it is wrong, you feel free. Then only if you are wrong, it is not finding fault. We tell what is technology behind it. Whatever you know, particularly easy students also sitting and seeing this stats. So you open the mouth.
See, till now I have had around 55, 60 workshops so far across the country.
Scientists from NRL came here, just now we talk about it. What he is feeling is the young generation, some scientists may be found from this. Some scientists must be there, required for the nation. This was one of the elite group. They are successful because of young mind. So be open up your thoughts.
So I'll tell you the best audience. It's the high school students and below that. Because they don't care what I think, they tell whatever comes to mind. However stupid or silly it seems. And that is best actually. Because you talk, then we know if it is right or wrong, right? And okay, alright. So whatever they said, yes, that is all rockets. But basically rocket is a vehicle, right? If you have to go to space, what kind of transportation that comes to mind? What do you think is available for you to go to space? Well, you cannot take your motorcycle, car, even aircraft, nothing, right? Can you think of anything else that you can take to go to space? Right, so rocket is the only vehicle that you have, right? So rocket is basically a vehicle, okay? So whatever you put in that vehicle, it depends on you. So whatever he mentioned, a payload could be anything useful that you put inside the rocket. It can be an astronaut, it can be a satellite, it can be a rover, a robot, or even animals. You know, people send animals, right? They send all kinds of animals: monkeys, chimps, mice, fruit flies, dogs, cats, for experimentation. So that is also a payload. A payload could be anything which is useful which is inside the rocket. One more interesting payload, like so far launched in the history of rocket is, have you heard of SpaceX, a company called SpaceX? Please tell me don't. No. You all live at present with your phones and stuff. You should know that company. You scroll Instagram Reels and YouTube Shorts, right? I'm pretty sure the Reels might have come up. Elon Musk, at least. So you know him, you don't know SpaceX. Okay, so that person launched his own car. So he used to drive a Tesla Roadster car. So for his first rocket launch, his private company, he put his own car on top of the rocket and launched off. And right now it's in an orbit between Earth and Mars, even now, on like outside space. So yeah. Okay, here's another question. Who's the father of rocket? Come on, you have passed your schooling and all the other stuff. This might have come up somewhere. Who's the inventor of rockets or the father of rockets? At least take a guess. Someone? Okay, forget the name. Which country invented rockets? Come on. Which country invented rockets?
America.
America? Okay. Nice. German? USSR, Soviet. Okay. Any other guesses? No patriotism? No India? Nothing? Okay. Russia, India, USSR, America, Australia, all the names except what I'm looking for. Yeah, it was made in China, by the way. Rockets were invented by Chinese. Alright? I'll tell you that story, how that happened. But when someone asks you who invented rockets or who's the father of rocket, it's not one person, there are three people who are involved in this, right? And that's why we call it as fathers of modern rocket. A German, an American, and a Russian. So, any idea who's the German here? This name? I cannot lip read, people, sorry. You need to talk. Who's the German? First, second, at least action. I can understand action. Lip reading, no. Second one?
American.
Robert?
American.
Yeah, Robert is an American. It's a typical American name. German. Third one, of course, yes. Hermann Oberth is the German. The first guy is a Russian. So, whatever name looks like a tongue twister, you can assume it's Russia. Anyone dare enough to pronounce that first name? Just take a thing. The best answer I ever got was from a third grade student. He stood up, he shouted, perfect pronunciation. Just take a guess. How do you pronounce that? No matter how you pronounce, we cannot come up with the right pronunciation because the way the Russians speak is different. The way they pronounce the R and the other things, right? But it's something like this: Konstantin Tsiolkovsky. Start. Okay. I'll show you who that person is. This is the guy. He was a school teacher, Russian school teacher, and he went on to invent this tiny equation called as the very famous rocket equation. So he's the person behind that. Okay? That's the equation. I'm not going to tell you what that equation does. But if you want to design rockets, you need to know that rockets. Okay? So it's kind of a derivation of your Newton's F equals ma equation. And any guesses who this guy is? Come on, he looks like an American, typical American, right? It's Robert, right? And this is the rocket he invented, by the way. Okay, on the right side, that is the rocket he made. And the reason why we call him as father of rocketry is he was the first person to use liquid fuels. Way before him, all the people were using solid fuels. I'll tell you what those things are. But this person showed that you can also build rocket engines which can use liquid fuels. Give me examples of liquid fuels. You have to think for that. Petrol, diesel, kerosene. Right, yeah. So yeah, this person used a form of liquid fuel. Okay? It's a big deal, by the way. You might think that, what's the big deal about that? Why do we call as a father of all the current rockets which use liquid engines? This is the pioneer behind that. Okay? And he is the German. You all know the stories of World War, right? The Nazi, Germany, Hitler and all this stuff. If you really are into those kind of things, you will know about them. Very interesting stories. Okay? And let me show another picture, which, can you see the guy who's sitting on the table on the right? With a grey blazer? Any idea who that is? Have you seen him on TVs, papers or anything else? No? Okay, just remember his face. Both these people, Hermann Oberth and his student, they both worked under Hitler during World War. Okay? They were rocket scientists and Hitler wanted to destroy nations. So he comes up to these scientists asking, I need a rocket to launch bombs. Right? So bombs were being transported in ships, planes and stuff. So not that fast, right? Not that far. So he wanted to transport bombs between nations, continents. So his idea was put a bomb or an explosive on a rocket and launch it off so that it can go to another continent. That's how the ICBM, Intercontinental Ballistic Missile, was born. All the ICBMs which India has is Akash and other missiles and all stuff. These people are the pioneer. This is when it all started. Okay? Yeah, so clear, right? Fathers of modern rocketry? German, American and Russian. Don't need to memorize the names, that's fine. Right, this is the short story. How Chinese invented rockets. So back in those days, you know these dragon festivals, right? Which they celebrate with a lot of fireworks, sound, music and stuff. So they were very much into these fires and explosives. So back then, they used to take a bamboo tube. You know, bamboo tubes are hollow. That's how we make flutes, right? They used to take these tubes, fill this with gunpowder. Gunpowder was also invented by Chinese because they love fireworks. Alright? It's a powder which is black which burns. Okay? And they used to fill this tube with that, close both ends of the tube, and they would toss into the fire. What do you think happens? Of course, boom, right? It's an explosive. So that they used to enjoy. But once what happened was, one of the closed ends came out loose, and instead of an explosion, all the gases which was burning inside came out from the one end, and the tube shot into the sky. So that's how they got an idea. Why don't we use this as a rocket? The first thing they did was take this tube, attach an arrow, and launch it towards the enemies. So that's the story of these fire arrows. Okay? Can you see the right picture? That's how they used to launch. Now there was another thing in India who also copied these designs and used it in our war. Who's that thing? This was in papers actually. It's not recent, but yeah. A king in India who used these rockets against British. You don't have to know those, at least take a guess, no? Some famous kings that you know. What? Shivaji? No. Akbar? No. You're close, yeah. Yes, it's Tipu Sultan. These people used rockets against British people, okay? So instead of bamboo tubes, they used iron shells, right? So iron is kind of very hard. You can fill more black powder in it and it used to travel farther. Actually, I don't think it's recently, but they started digging places in Mysore and they found a lot of iron shells of these rockets. So, yeah. So remember, this is how the technology from China is coming to India, the rockets. And from India, you know what happens with the war, right? British people looted. They also looted the rockets. They went to their own country and renamed this rocket as William Conway rockets. So technology again goes from India to British, and from there it spreads all over the world. So this is how the rocket tech became very famous across the world. Clear? That's a history. Okay? Chinese invented, went to India, went to British, and it spreads everywhere. Yeah. So you know about liquid propellant. So all these Chinese, British rocket uses liquid propellant. Sorry, solid propellant. This rocket also uses solid propellant. Okay. Solid propellant simply means a fuel which is solid. Okay. Yeah, German V2 rockets. So when Hitler asked Hermann Orbit and a student to come up with a rocket to launch bombs, this is what these people came up with. Very fancy looking rocket. It's called German V2 rocket. Okay? And you see the tip of the rocket? That is where the explosive is. Alright? And the name of this, it's not called as a rocket, it's called ICBM, Intercontinental Ballistic Missile. Because it hops between continents. And it will come in a vehicle, place it wherever you want, and put it at an angle and launch. It will go almost to the space and it will fall back in a trajectory wherever you decide the continent. Okay? Immediately after this, you know what happened to Hitler, right? The Nazi lost, and fearing of losing life, these people were escaping to different nations, thinking that I'll go to some nation and seek protection. So the student of Hermann Orbit, his name is Werner von Braun. This guy escapes to the US, thinking that they might look after him because they have a lot of knowledge in rockets. So immediately the US saw the potential. Actually, there were two groups of scientists. One group were captured by US, and another group captured by USSR, Soviet Russia. So that space race, whatever happened between them, they were all German tech, not their tech. Germany is the one who was specialized in rocket making. Okay? So this Werner von Braun went to US, and he's the one who made the Saturn V rocket, which carried Neil Armstrong to the moon. Okay, that is that person. So these are the ICBMs, very similar to German V2. So all these rockets developed by all these nations were used for just one purpose alone. What is that? Just one purpose. All these fancy looking rockets. Simple, killing humans, right? Humans love killing other humans. So they all came up with these fancy missions for that. This is Atlas Agena rockets from US. Jupiter class missiles again from US, and then this person comes up again, the Russian school teacher, telling, why don't we use all these missions to put something in space rather than using it to like transport bombs? And people knew this idea existed, but they weren't very interested, because why should you do that? It's very fun with wars and stuff, right? And then Russia actually started that. They immediately, what they did was, they converted one of their missile into a vehicle which can go to space and place an object. The first satellite man ever launched into space. What was that? Nothing? No, monkey is an animal. Satellite. There was, what do you call that? Vaccine named after that. Come on, COVID vaccine. Yes, Sputnik. No one from you have heard of this vaccine, no? Sputnik, the Russians. So that is the first satellite to go into space. And this is the rocket that launched that. This is a very special rocket because this is when humans stopped using, they did not stop. They started using rockets to send useful objects to space. Okay, it's called R7 Semyorka. And immediately what US did, well, US thought if they have that tech, whatever they develop will be like very advanced. So we also have to be in that race. And they converted this ICBM into a useful rocket which launched their own satellite called Explorer 1. You have heard of space race, right? Space race between US and Russia. Who won that war? No idea? You all need to get updated. ASAP. This is not very scientific knowledge and stuff. These are all basic things. Okay? US won. We were launching Neil Armstrong to the moon. The Russians lost. And I'll show you that once again. Yeah. The name of the rocket that was responsible in launching Neil Armstrong was Saturn V. The name of the mission was called Apollo. The person who was responsible in designing this is Werner von Braun. Okay? Have you seen these pictures before anywhere? This is the biggest rocket mankind has ever built till date. It's called Saturn V. I'll give you a comparison of how big this is. Have you seen any big apartments, like beyond 30 stories, 30 floors? Okay, forget that. Cell phone towers. You know cell phone towers? You know what is the average height of cell phone tower? In meters, feet, whatever, 50. So you can stack around 2 to 3 of that. So that's how big this rocket was. Very huge, like a skyscraper. Okay? And the engines of this rocket consumed so much fuel. You know these petrol tankers which refuel these petrol bunks, right? The lorries carrying petrol. So this one engine empties that whole tanker in 1 second. So every second it uses that much fuel. One engine, and this has 5 engines. Imagine the power it generates during launching. All this was necessary to launch 3 humans to the moon. Okay, that's how much power we need. And you see that tip, that tiny rod kind of thing? The astronauts were placed just below that. 3 people. Neil Armstrong and who was the second guy who landed his feet on the moon? Any idea? Come on, he's a very famous guy. You have cartoons and characters named after them, toys even. Buzz Aldrin, people, Buzz Aldrin. Rakesh Sharma was an Indian. He was the first Indian to go to space. Okay. Yeah, so this is the close-up shot of that rocket. So right now this rocket is not existent, meaning they retired this rocket, no one uses it. You can only find these rockets in museums. Okay? So, any idea what that rocket is? What? Have you heard of a person named Kalpana Chawla? Who is she? First? Yeah, someone said it right actually. Here, this side. Right, Indian origin, American citizen. She's not exactly Indian. So, yeah, women to go to space, right? So she went in that rocket. So the name of the rocket is called Space Shuttle. Soon after Saturn V went out of picture, the Americans wanted to build another rocket which can carry more than 3 people, 6 people at a time. So they went with all the designs and they decided this is the best design. And this was the worst design actually, but they figured out towards the very end when the rocket exploded and a lot of people died. Okay? And yeah. So remember, I'm coming from Chinese fire arrows all the way to missiles, V2, German V2 rockets, and this. Okay? History. I'm skipping a lot of steps, but yeah. Anyone know this rocket? First row, no answers, please. Guys, come on. Social media content. This was in social media. This was like a hyped up news everywhere when this happened. Literally everywhere. No one? I also told the name of the company, right? Before in the beginning.
Elon Musk.
Yeah, so that company, right. So why I talk about that person is, he showed to the world that private companies can also build rockets and launch successfully to the space. Right? Before that, people thought only governments can do that. Example, ISRO. Can you think of other companies who launches rockets in India? Well, there are companies, but they haven't launched it yet. But ISRO, right? Again in America, it's NASA, government entity. But this person showed, well, government is like kind of old school. Private players can also build rockets. And he did it better, right? Imagine you launch the rocket once and you discard it. And if you have to launch it again, you need to build it from scratch. Lot of money, right? So this guy is like, why don't you reuse the rocket so that instead of discarding it, you can like use it and cut down the cost. And this was the first time he did it. His rockets launches space, stuff into space, comes back and lands on the launch pad. So that you can do maintenance, put another payload and send it back. Okay? Straight from the books, like sci-fi books. Yeah, this was another company called Blue Origin. Anyone any idea about Blue Origin? No? The CEO of Blue Origin at least? Who is the CEO of Amazon? Guys, come on. Amazon CEO. He was at some point richest person in the world. Right, Bezos. So he was also the founder of this company called Blue Origin. And by the way, if you would like to go to space and you don't need a degree or go through the extreme astronaut training, you can simply buy a ticket and go. So this company sells tickets. Very costly though, but still, you can go to space as a tourist. Okay? And this is another company which again came up with the space tourism. I don't know, you might have. Richard Branson, have you heard of this guy? Okay, yeah. It's a Virgin Group of companies. So he also co-founded this company where they make rockets like that, which is super cool. Looks like this sci-fi film stuff, right? But this is an actual rocket which do. And astronauts sit here. This is carried by another huge plane. Okay. And the current news. Alright, this is the present, whatever is happening in the space industry. Any idea what this is at least? Same thing, SpaceX. So the name of the rocket is called Rocketry. You know why Elon Musk started space company? Any idea? He has so much money, he could have been doing a lot of things, but he started SpaceX.
Mars.
For just one reason. Why? Yeah, he wanted people to settle on Mars. His only goal. All the other companies which exist of Elon Musk is to pump money into SpaceX to make this goal possible. If people would go and live on Mars, I think this is the company this is the only company that will do it at the rate which they are progressing. And this is a rocket which they are building to achieve that. The name of the rocket is called Starship. Okay? So every few months once you'll see this rocket exploding, the news channels. So yeah, that's how they develop. They build, they destroy, again they build, they destroy. So that they learn faster and build like proper rockets. And this is the latest rocket from NASA. It's called Artemis. After this Apollo mission, you know how many people landed on moon by any chance? In total? Elon Musk was the first human, yes. But how many humans in total landed on moon? No one paid attention after Neil Armstrong and Buzz Aldrin. They stopped actually. At least 11 of those rockets flew, with 3 humans each. That many humans, remember, right? And after that, no one went to moon, ever. Any idea why? It's an engineering problem. I hope there are engineers here, right? About to be engineers. So why did we stop sending people to moon? Here's another interesting thing. The computer which was used in the rocket which sent Neil Armstrong to the moon, you know how powerful the computer was? I forgot my watch. My smartwatch has computer which is at least 1,000 times powerful than the computer which was on Saturn V. That flimsy computer launched humans to moon and got them back safely. But now we cannot send humans to moon. Why? Any reason? Apply logic. and some maybe engineering knowledge, irrespective of your branches. No one? No one? Take some guesses, smart guesses. Is there any protest happening that telling you cannot talk or something? No, right?
1 million less.
Sorry?
1 million less and
At least some answer. I want you to talk. It's good. Fine. I'm not going to tell why, but okay, you can figure it out. I really hope you all have chat GPTs and stuff. You do?
money.
Yeah, okay. Good, at least. Clear, right? Chinese fire arrow still Artemis. That's the evolution of rockets. That's how we started, and this is where we are. And okay, I'll skip it to the end. I really did not discuss about ISRO, by the way. I saved it towards the end. I'll stop for this, okay, last slide. Don't worry. Yeah, that is one of the engine of Saturn V. And that rocket has 5 of these, imagine. And this whole engine moves left and right, like all directions, to control the direction of the rocket. Interesting stuff. Okay, so forget about space programs of other countries. Our country, ISRO. You know the rockets we use, right? Yes, at least that is. Even if you don't. Okay, yes. Right, anyone know a story behind this? Which is kind of a very, what do you call that? Misinformed, misnomer fact, which people circulate in media. ISRO used bullock carts to transport satellites, and they came from that till this. Well, not exactly. It's part of an experiment, right? So they wanted an environment without this EM interference and stuff, without metallic objects. So that is why they kind of used bullock cart to do that test. Desi version of proper experiment, but yeah, proper experiment. All right. They weren't transporting, by the way. You know what is that satellite? Anyone? Any guesses? What is the name of that satellite? Very beginning days of ISRO, very early days. Apple. The name of the satellite is called Apple, our first ever geostationary communication satellite. Any idea who are these people in the picture? Come on, people, take guesses. There is one famous person, of course, in the picture. Right. Where is he? On the extreme right, yeah. Who is the extreme left person? Yeah, the person because of whom ISRO exists. There was a television series made after these people, Vikram Sarabhai, Abdul Kalam, and all the stuff. By any chance, have you watched it? If you haven't, you should watch it. Anyone? What is the name of the series? Rocket Boys. If you haven't, please do it. Okay? It's very well made. You know who these persons are and what are the roles they have played. So that is Dr. Vikram Sarabhai on the extreme left. On the extreme right, that is Dr. APJ Abdul Kalam. This is our very first sounding rocket, like Apache. We did not make it, we borrowed it, but we also did something on our own. Okay? You know which place is this, where they used to launch these rockets in the beginning? In India? It's a beach, yes, but where? Kerala, Thiruvananthapuram, right? They had a church there, and these people convinced them to give the church to ISRO. It wasn't called ISRO before, it was INCO's Power, something, right? And that is where they used to make all these experiments and launch rockets. And the person who's standing in the center is Professor Satish Dhawan. You know which rocket is this? This is again ISRO's rocket. But what is the name? SLV, yes. This is one of the very first launch vehicles. And unlike other usually launch vehicles will be built vertically. They'll stack vertically and the structure will move and the rocket will get launched. But here they decided to integrate it horizontally and lift it. Like again, a very unusual method to build and launch rockets. But yeah, very first launch vehicle of ISRO. And this is after celebrations, after the launch being successful. Yeah, with all these are all the very first ISRO employees, by the way. All black and white pictures. Yeah. So any idea when was this happening? I did not put this in the history of rockets because this existed in a separate timeline, right? Because we came to this whole space tech very late. By the time these people did all this, people had already landed on moon, right? It was very hard for us to catch up with all those progress because of the country, the government, all this stuff. Okay? So that is why I kept all these stuff towards the end. Okay, yeah. Any questions so far? No questions at all? Are you serious? Sleeping? Opening your eyes and sleeping? No, I know that's a technique. I know how that works. Was it interesting at least? So you haven't heard of any of these stuff before, right? So at least you know something about rockets and things. So, okay, one more important thing. Whenever I talk to students, specifically engineering students, they think if you have to get into this industry, making rockets, you have to get into which branch? Okay, ma'am is telling mechanical. What else? There's another common branch which comes up. Aeronautical, aerospace, right? Well, you don't have to take that. Almost all the famous rocket people which I discussed, they all have degrees in mechanical. Even current, all the top rocket manufacturers. I don't know if you have heard of this engineer called Tom Mueller. So when you talk about rocket engine design, he's the celebrity in the world. Elon Musk's first employee to build rockets. That guy also has a degree in mechanical engineering. So if you want to build rockets, mechanical is the best, right? And mechanical engineers alone won't build rockets. You also need computer science, you need electronics and communication, you need even civil to build the structures around rockets that makes the rocket launch possible, chemical engineering, rocket propellants, right? So almost all the branches are needed to build rockets. It's not that you need to pick aerospace specifically. Okay, I want to close this with that. Any questions before? Okay, now bye. So I have a couple of more rockets which I would like to launch, and so this is that. As I told you, if you would like to learn rocket science at early on, this is the best way, right? Textbooks, videos help, but if you build rockets like this and launch, then you can validate whatever knowledge you have, how these things work, right? I have assembled this rocket. Launching this won't teach you anything. But if you build this from scratch, including the engines and the design, you have softwares to design these things. So if you do this from scratch, then you'll have a very rough and very nice understanding of how these things work. Okay? And yeah. So you were there in the morning, right? I couldn't tell you a lot of things. I'll take 2 minutes to explain how this is done. So there is a black powder based propellant filled inside this end. You know what is black powder? It's gunpowder, right? Water powder people use in bullets. Same thing. But this has a bit of more additives. But basic composition is sulfur, potassium nitrate and charcoal with few more additives. Don't ask me the recipe and stuff. Okay? Bad idea to experiment on your own. Never do this. And also if you need to buy black powders and stuff in India, you need to hold an explosive license. So I'm telling all the rules and stuff so that you don't buy anything fishy. Right? And also these are all best to do under a college. Okay? With the help of professors or chemistry department. So it's always better that way. So we use that fuel, around 10 to 12 grams of that. And this rocket will go roughly to 300 to 400 feet. Okay. If you make this rocket even lighter, it can also go beyond 500 to 600 feet. So we have managed to send this rocket all the way to 900 feet max by making this very light. So this bunch of propellant is enough to push a rocket that high. And also sometimes we use parachutes to bring this back, right? You know how this, okay, you weren't there. So once you launch this rocket, it goes to 300 feet and it turns back and it drops. It's a free-falling object, right? Since it is light, we don't mind because it won't harm anything. But if the same rocket is heavier, you cannot let it free fall. You might have seen that in the video. Things going into the ground, buildings, cars and all the stuff, right? So in that case, you need to recover the rockets with parachutes. Okay? So, which, again, entirely another class, you have a lot of simulators and software to design parachutes specifically for rockets and stuff. But understand, rockets use parachutes to bring back safety, come back safely. And also there is a competition which is going on. ISRO is also coming up with another competition, I think, where you get to design, build and launch rockets. Okay? So, very amazing program. You don't have to know anything about rockets. You can actually go to ISRO, they train you, they give you all the materials. You can be there in the facility, learn and then you can launch. Wonderful opportunities. Okay? That is why just go online, be aware of all these things. Okay? Yeah. Thank you. So after this, what we can do is, do we have any other sessions? We can go for the demo. Okay. So 10 minutes, we'll go set this up in the ground. Then you can come to the same ground which you came in the morning. Okay? And then we'll see how this thing flies.
Yes, sir. Thank you.